Alrighty, so hopefully you got this warm-up done. Let's take a look at it. So for this one, we're looking for x and y, which are the legs of our 45, 45, 90 triangle. So it doesn't matter which one you find first, because remember, for a 45, 45, 90, the setup is x, and square root 2 times x. X square root 2. So x and y are actually equal to each other. So once we find one, we found both. So to get from the hypotenuse to the legs here, we have to divide by the square root 2. So 6 over square root 2. But when we divide by square root, we can't leave that in the denominator, so we have to multiply this by the square root 2 over square root 2. This gives us 6 square root 2, and when you multiply square root 2 times square root 2, that just cancels the square root, leaving us with what's inside 2. And we have to simplify further. 6 square root 2 over 2 is 3 square root 2. So today we're going to be talking about right triangle trigonometry. By the end of the lesson, you're going to be able to find the opposite and adjacent legs when you're given a reference angle for a right triangle, understand the definitions of sine, cosine, and tangent ratios, calculate the trigonometric ratios in a right triangle, use trig ratios to find unknown side lengths in right triangles, calculate angle measures from trig ratios, and solve right triangles, which means finding everything you can, the legs and angles entirely, for a right triangle. Or when you solve a triangle in general, that's what you're doing, is finding all the angles and all the sides. So first things first, looking at this picture here, how long is the hypotenuse? We don't know, right? But we do know that one of the legs is 23 centimeters, and one angle is 55 degrees, and we know it's a right triangle. So how do we find the length of the hypotenuse if we only have one side length and one angle measure? Well, we can't use Pythagorean theorem. Can we use special right triangles? Let's find out. Answer this next question.